recurrence equation example using the advancement operator where we're not in a homogeneous setting. So everything we've done so far in using the advancement operator has been homogeneous. So now let's see what happens if we do not have homogeneity. So let's find a function f mapping, again, the naturals union 0 to the reals, satisfying, and I've got some sort of strange initial conditions just to make the equation work out nicely. So I've got f of 0 is 13 over 3. I've got f of 1 is 8 over 3. And then my recurrence that I'm going to get is f of n plus 2 is equal to f of n plus 2 to the n. So here, this is non-homogeneous because when I go through the advancement operator section, I'm going to have a right-hand side not equal to 0. That is to say, this is a linear combination of terms of f of n, different terms of f of n, but then there's something else there. There's some other function. So let's go straight to the advancement operator part, and what I'm going to get is I've got a squared f of n equals f of n plus 2 to the n. And if I do what I've done previously, I'm going to get a squared minus 1 f of n equals 2 to the n. And this left-hand side is going to factor, and this is going to be a plus 1 times a minus 1 f of n equals 2 to the n. Now you can really see this is not homogeneous because that right-hand side is not equal to 0. And that's going to be fine. We're going to have a way to take care of that. But first, let's deal with the homogeneous part. Let's just pretend that it's homogeneous. And we're going to look for the solution to a plus 1 times a minus 1 times f of n, or a plus 1 of a minus 1 of f of n equals 0. And by looking at this and having done several of these recently, you should already see that the answer is going to be we're going to have f1 of n is going to be this c1 times negative 1 to the n, and f2 of n is going to be c2 times 1 to the n. And that's going to deal with the homogeneous part of this. Now what we're going to want to do is deal with the non-homogeneous part. And to deal with the non-homogeneous part, I want to guess the shape of the non-homogeneous part. And at this point, I'm sure you're sick of hearing it, but if you've seen differential equations before, you've probably got some idea where we're headed. If you haven't seen differential equations before, maybe you don't know exactly where we're heading, but hopefully you can just trust that this tends to work. And what we're going to do is we're going to pick another part of our equation to look something like the inhomogeneous part. So I'm going to now find non-homogeneous. I'm looking for a solution that takes that into account. So I'm going to go back to the original equation, and I'm going to write f3 of n plus 2 equals f3 of n plus 2 to the n. So now I'm looking for some solution here, and so I'm going to guess that f3 of n is going to be some constant c3 times 2 to the n. And this is the part where if you've seen differential equations before, that's probably not a surprise. If you haven't seen differential equations before, it might be again sort of coming out of nowhere. But if you watch how things move forward, it should come together and make sense. So now let's plug that in here, and I'm going to have c3 times 2 to the n plus 2 is equal to c3 times 2 to the n plus 2 to the n. Now if I divide both sides by 2 to the n, I'm going to get c3 times 2 squared equals c3 plus 1. And this tells me, well, I've got 4c3 equals c3. I can subtract c3 from both sides. And this is going to tell me that c3 equals 1/3. Right. So the part of my function f3 is going to be of n is going to be 1/3 2 to the n. And now hopefully I can take all three of these components, put them together, and find the final answer. So my final answer is going to be, f of n will equal f1 of n plus f2 of n plus f3 of n. And I'm going to need to find these constants, C1 and C2. Well, I'll do that by, again, plugging in my initial conditions. So first initial condition, 13/3 equals f0 equals, f1 at 0 is going to be c1 times -1 to the 0, plus f2 at 0 is going to be c2 times 1 to the 0, plus f3 at 0, which is c3, I know c3 is 1/3 times 2 to the 0. Next, I plug in 8/3 is my next initial condition, and that's going to be c1 times -1 to the 1 plus c2 times 1 to the 1 plus 1/3 times 2 to the 1. Now if I work really hard and do the linear algebra, these, I guess I've got room on the display surface here. I can write 13/3, no. Let me write it like this. I'll write c1 plus c2 equals, and then I'm losing 1/3 equals 12/3 or 4, and then I've got negative c1 plus c2 equals, and I'm losing 2/3 from this, equals 2. So I've got numbers that add up to 4 and that have a difference of 2, and this should tell me that C1 is going to be 1, and C2 is going to be 3. Right, so 1 plus 3 gives me 4. -1 plus 3 gives me 2. So 1 and 3 should solve this system of linear equations, and my final answer is going to be f of n equals c1 times 1, so -1 to the n, plus c2, that's 3, times 1 to the n, plus 1/3 times 2 to the n. Now this 1 to the n, you can just write it as 3. You don't have to write it as 3 times 1 to the n, but that just kind of shows you where each piece comes from. And that's the last thing I wanted to do with this section.